to say the message is eat. 0, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, 19. I want to change the message to ear. Sorry about that. Is R correspond to 17? Is it the 18th letter? Check me on this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And we always do A at 0. We always do A being 0. Always, always. So this is 4017. Let's look at an encryption where our key is something like, we want to take our number, so our key is going to be a multiplier and a shift. And I'm going to say that the multiplier is 8 and the shift is 1. So I'm taking whatever the number is and I'm mapping it to 8 times the number plus 1 mod 26. So I do 4 times 8. Or I do 4 goes to 8 times 4 plus 1, which is 33 mod 26, which is 7, which is, I got H. Do you agree? Okay. 0 is easy. 0 goes to 8 times 0 plus 1, which is 1 mod 26, which is B. We always put A at 0. And the final piece, 17, goes to 8 times 17 plus 1. We have to figure out what that is, so that's in 37. Yes, okay, then we got to do 137 mod 26. So that's 130, which is 7, which is H. So I start with ear, and it maps to the message H, B, H. Yeah, there are 2 H's, right? But one of those H's we intended to represent E, and one of those H's we intended to represent R. Do you see why that's an issue? When our recipient gets this message, and they're trying to decode what we sent or decrypt what we sent, you can't have one H that we magically know goes back to E and one H that we magically know goes back to R. We need H to consistently go to the same letter. But we have 2 letters in the ciphertext alphabet. The letter in the ciphertext alphabet that corresponds to 2 different letters when we go to decrypt. And then the question is, well, how do we know which one to do? Because if we have to go through and figure out what H should go to each time, that's not going to work. It's going to take way too long. So did we do anything wrong on the encryption? I don't think we did. I think that we actually did the math correctly. That we calculated this 8 times number plus 1 mod 26 correctly. So what's the problem? The number I chose to multiply with is a big issue. Because what happens here is that 8 times 13 is equal to 4 times 2 times 13. Do you agree? Is equal to 4 times 26. Do you agree? Is equal to what mod 26? What's 4 times 26 mod 26? 0. So what does that mean? That means if 2 letters are 13 apart, like 4 and 17, so E and R are 13 apart, then you're going to have 8 times X, or 8 times the letter. Is it okay if I use X? Y'all know that I'm not really talking about the letter X, that this is just a number, right? Well, this is equal to 8 times X plus 0 plus 1, right? You can always add 0, it doesn't matter. But we said that 8 times 13 was equal to 0, so this is equal to 8 times x plus 8 times 13 plus 1. And then we can factor out this 8, and we get 8 times x plus 13 plus 1. And x plus 13 aren't the same thing. So when you work with 8 here, anytime that you are working with two letters that are a distance of 13 apart, they're going to get mapped to the same thing, and that doesn't work. So 8 doesn't work as a multiplier. It works just fine as a shift, but you cannot use 8 as a multiplier. You end up destroying information that can't be recovered. So what are some other numbers that we could not use here? 8 is a bad choice for multiplier. What else would be a bad choice for multiplier? 4. 4 doesn't work. What else wouldn't work? Well, what was the problem here? The problem was that 8 times 13 was equal to 0 mod 26, right? So what else could you multiply by 13 that would give you 0 mod 26? Any multiple of 2, why do you say any multiple of 2? Okay, so 2 times 13 is 0 mod 26, right? But then as soon as you start multiplying it by anything, like 2 times 2 times 13, is still going to be 0 because this is 0. So 4 times 13 is 0 mod 26. 6 times 13 is 0 mod 26. Do y'all see what I'm saying here? Another really bad choice. It's even worse than any multiple of 2. One's not great. 1 is a bad choice. What happens if you choose 1 as the multiplier? And if 1 is the multiplier, you get a Caesar cipher. Because you're still shifting, but you're not adding any security by your multiplier. And the other bad choice is 13. Because there, if you have things that are 2 letters apart, like you can look at, this is a quick message, A, C, E, and you pick your multiplier, 13, and your shift can be whatever, 2. And A, which is 0, gets sent to 13 times 0 plus 2. Which is 2, which is C. And C, which is 2, 13 times 2 plus 2, which this is 0 minus. So this is 2, which is C. And E is just 4. Goes to 13 times 4 plus 2. This is also 0 mod 26. Which is 2, which is C. So your entire message here just becomes C, C, C. Can you decrypt this to anything? No.
It's a very secure thing.
It's very secure. The one problem is it lets you know how long the message is. And in modern applications, you shouldn't even know how long the original message was. So it still leaks a little bit of information, even though it's terrible. So the bad keys here are, or the bad multipliers are the evens and 13. And the reason these are bad multipliers is that you can multiply to get 0, even though neither one of them is 0. So these are what are called 0 divisors. Mod 26. And that's what's weird about working mod. Sometimes you have 2 things that multiply to be 0, but neither one of the originals was 0. You want to avoid the 0 divisors because then you get this situation where you're multiplying and you're getting, all right. So here.